Cellular concept. Traditional mobile service was structured similar to television broadcasting. One very powerful transmitter located at the highest spot in an area would broadcast in a radius of up to 50 kilometers. Cells are formed by dividing a metropolitan region into 100 different areas with low power transmitters. The cellular concept employs variable low power levels, which allows cells to be sized according to the subscriber density and the demand. Frequencies used in one cell cluster can be reused in other cells. Conversations can be handed over from cell to cell to maintain constant phone service as the user moves between the cells. A cell is the basic geographic unit of cellular system. They are the base stations transmitting over small geographic areas that are represented as hexagons. A group of cells is called a cluster. No frequencies are reused in a cluster. Digital cellular systems have the following features. Cells are small, frequencies can be reused, small battery-powered handsets are used, handovers are important, and its performance is evaluated. Functions of BTS. The BTS provides the physical connection of a mobile station to the network in form of air interface. On the other side, towards the NSS, the BTS is connected to the BSC via ABIS interface. GSM recommendations allow for one BTS to host up to 18 TRX. Each frequency is given a number called ARFCN, Absolute Radio Frequency Carrier Number. Majority of the BTSs host between 1 and 12 TRX. 3 sector each with 3 frequencies, that is 4 plus 4 plus 4. Functions of BTS. The first function is radio transmission and reception done by TRX card. Modulation, demodulation, equalization and digitization of voice and data signals coming from the air interface. Combining and coupling of RF signals to antenna. Mapping and transmission of information from BTS to BSC. Alarms generation and control of overall BTS system. Maintenance. The important steps are: Step 1. Enter into the BTS room or the shelter. Do the physical examination of the environment. Check for fire, smoke, humidity, and any physical damage to BTS or the infrastructure. If everything is okay, proceed to step 2. If any alarms are available, go to the subsequent step or go sequence by sequence. First, check the control card and its LEDs. Generally, it contains the media termination also. So, check for the media LED if media is down. Verify by giving the loop in both directions. If okay, go to the next step. Step 3. If control card itself is faulty, replace it with new one or tested card from other site. Also try to reset the control card so that software can be reloaded to it. If possible, locally access the control card and try to identify the fault. Step 4. If media and control card both is okay, then proceed to the TRX card. Check the LEDs on the TRX card. Mark the TRX card which is showing fault. Step 5. If TRX card itself is faulty, then only in one sector some frequency will not work, or sector will not work if BCCH carrier is down. Replace it with new one or from tested card from other site. Here BCCH stands for Broadcast Control Channel. Step 6. If TRX cards are OK, check the coupler card and also the status of RF jumper cable connecting the output of TRX or coupler to the antenna. Look out for VSWR reports. Consult with the OMCR team for physical test and media test. Now, if configuration is proper, the BTS should be up and radiating. Step 7. If BTS is radiating and calls are not landing, check whether the BCCH channel is assigned or not. If not assigned, assign it. Also check the BCCH channel should not be on hopping frequency. Check the availability of SDCCH channel. Here SDCCH stands for Standalone Dedicated Control Channel. Step 8. If BTS is radiating, calls landing but are not maturing, there can be crosstalk, call drop or interference. Check whether the BCCH channel is assigned or not. If not assigned, assign it. Also check the BCCH channel should not be on hopping frequency and whether the cable has not been swapped. Also check HSN and MAYO with adjacent sector. Here HSN stands for hopping sequence number. MAYO stands for mobile allocation index offset. Alarms in BTS. There are two types of alarms. External alarms are external in nature and are caused due to environmental conditions or infrastructure failure. Internal alarms are internal to the BTS system. First, external alarms. Power plant and battery. Generally, BTS are inside other exchanges, so they take power from existing power plant. If not, at least 25 to 50 ampere module power plant with a 200 Ah battery set must be provided. The health of the battery is very crucial as at the most of the site it is seen that the BTS is off due to no battery backup and DG. Engine alternator working should be ensured. Air conditioning condition should be checked. The recommended temperature is 23 degrees Celsius plus 3 degrees Celsius. Fire detection system should be available. Tower earthing should be proper and separated from DC earth. Measure the earth resistance range and ensure it is within limits. Internal alarms are BTS fail, TRX card faulty, combiner faulty, combiner loss, swapping of the feeder cable with the adjacent sector, high bit error rate in PCM, power failure, media failure, fan failure. Maintenance issues of node B. Node B is the telecommunication node in a particular mobile communication network, namely those that adhere to the UMTS standard. The node B provides the connection between mobile phones and the wider telephone network. The node B corresponds to BTS in GSM. A node B can serve several cells, also called sectors, depending on the configuration and type of antenna. Common configuration is 3-sector. If RNC has fault, usually it will affect some sites or all the sites. If node B has fault, usually it just affects itself and the handover successful rate of adjacent cells. The common fault types are RAN fault and RNO fault. RAN fault means radio access network. There can be cell fault, traffic problem, link, interconnection, clock, antenna and feeder, transmission problems, software loading. RNO fault. RNO means radio network optimization. Can be problems in access, call drop, congestion, and handover. Operation and maintenance system faults. Node B provides two modes of operation and maintenance. One is near end operation, the other one is far end operation. The near end operation contains a kind of Ethernet interface that directly connects the base station with PC. Carry out the operation and maintenance by MML language, that is referred to as near end control. The far end operation and maintenance. The PC control desk is by far end operation maintenance center server, generally B2B positioned at the base station controller end, controlled by the OM channel that is based upon between base station and the base station controller. Case 1. Downloading software package lasts too long. Sometimes software downloading fails in the course of software upgrading. It takes several hours to download the software package, and sometimes the software downloading procedure fails. The troubleshooting method is: for maintenance over IP over ATM through RNC, check whether the IPOA bandwidth on RNC operation and maintenance system is too narrow. Increase the IPOA bandwidth to speed up the software downloading progress based on the actual situation. Case 2. Fail to log into the node B by near-end mode in near-end maintenance mode. The troubleshooting methods are: Step 1. Log into node B over IPOA link through operation and maintenance system. Configure IP for near-end maintenance channel by using the MML command set IP. Query whether the setting is successful by using the MML command lst IP. Step 2. Open the data configuration file on the configuration management system to modify the node B property. Modify the local IP address as the value demanded. Download the data configuration file again and then restart the node B. Cell faults. Case 1. No cell setup request message from RNC while node B in normal state. The troubleshooting methods are: Step 1. Check whether the maximum downlink power reported by node B in the audit message is smaller than the value configured by RNC. Step 2. On node B operation and maintenance system, use the MML command DSP cell to view whether the local cell ID is consistent with that specified in RNC. Case 2. Cell detected and set up repeatedly. RNC multi-frame out of synchronization alarm occurs. Cell setup fails. Troubleshooting is: the most possible cause for this fault is that even working mode for node B is not consistent with that of RNC, dual frame for node B and multi-frame for RNC. Case 3. RNC deletes cells after node B responds with cell and common transport channel setup. RNC sends a cell setup request message to node B, and node B reports a cell setup response message to RNC. Then RNC sends two common transport channel setup request messages. Upon receipt of the two common transport channel setup response messages from node B, the RNC sends a cell deletion request message instead of a system information update request message. There is no alarm in node B or RNC. The troubleshooting method is: this fault may be related to IUB interface user plane. The IUB interface is the interface between node B and RNC. In this case, it is necessary to check the user plane of node B and RNC in data configuration and hardware connection to see whether they are consistent. Node B fault prevention. Hardware installation specifications are most important. Pay more attention to event connector and feeder connector. Pay more attention to the waterproof of antenna and feeder system. Confirm the grounding and lightning protection. Checking the running status. Node B maintenance console. First, do a multi-site fault query. Then try to remove the fault according to the alarm description and suggestion. If you cannot remove the fault provisionally, confirm the reason of every fault at least. This is the flowchart for the LTE eNode B troubleshooting. First, we should back up the data, collect the fault information, check whether the fault scope and the type can be determined. If yes, go to the fault scope, identify the causes and rectify the fault. But if it is out of scope, contact the technical support and get it rectified. LTE service faults. The different service faults are access fault, where user access fails or access success rate is low. The other one is handover fault. The intra-frequency handover success rate, inter-frequency handover success rate may be down. Service drop faults. Service drops may occur during handover procedure, and sometimes services are unexpectedly released. Inter-RAT interoperability fault. Here RAT means radio access technologies. These are the handover between 4G to 3G or 4G to 2G. Rate faults. Data rates are low, or there is no data rate, or data rates may fluctuate. LTE equipment faults are cell faults. Cell setup or cell activation fails. Operation and maintenance channel OMCH faults. OMCH is interrupted intermittently. The CPRI link does not work properly. The CPRI link is the multimode fiber connected between BBU and RRH. Clock faults. The clock source is faulty, the IP clock link may be faulty, or the system clock is out of lock. Security faults. The IPsec tunnel is abnormal, SSL negotiation, or the digital signal processing, certificate processing is abnormal. Then comes the radio frequency faults. The standing wave is abnormal. The received total wideband power RTWP on the received channel is abnormal. The antenna line device ALD link does not work properly. The ALDs are the devices connected in the receive path. The license faults can be there. License installation or modification fails. Rectifying the fault. To troubleshoot a fault, take proper measures to eliminate the fault and restore the system, including checking and repairing cables, replacing boards, modifying the configuration data, switching over the system, and resetting the boards. Maintenance personnel need to clear different faults using proper methods. After the fault is cleared, be ensured to perform the following. Perform testing to confirm that the fault has been rectified. Record the troubleshooting process and key points. Summarize the measures of preventing or decreasing such faults in future. The conclusion. For proper working of network maintenance of radio network, we need to have proper maintenance. Day-to-day resolution of fault is very important. Thank you.